Good afternoon, everyone. So now, today we are going to, what is the topic about this folds, right? So now, what is fold? So fold is this bending, right? Bending of rock strata due to, what is the reason? Due to compressional forces. I already told stress, force and strain, right? Compressional forces acting tangentially on horizontal or horizontally towards a common plane from opposite direction. So that is known as folds, right? So the folds are folds are spectacular and noticeable structures. So that can form in practically any rock type, right? Any rock type means that is igneous or maybe sedimentary or metamorphic, right? Any rock type. So, however, they are best identified in layered um, rocks. So, they have been recognized and admired and explored by geologists and even non-geologists also. So, they are some of our most important windows into these local and regional deformation histories of the geological which one? Past, right? Past. So, what is the definition of this fold is folds are like this wave-like, right? Wave-like undulations in strata or foliations. So, they are bending, right? Like this, bending or arching in the bedding or this one bedding or this foliation planes of the rock layers due to forces of the earth, and this folding is commonly observed in which rocks, the layered rocks, right? Layered rocks. So they are best displayed by stratified formations such as sedimentary, layered volcanic igneous rocks or metamorphic rocks. These three types of rocks. So the folds in rocks are like folds in clothing, right? It's look like clothing. So just as when a piece of cloth is like that pushed together from this opposite, right? Opposite sides, it buckles up in the form of folds. So that is similarly that layers of rock when compressed like this, compressed, right? Compressed by which one? Forces. Forces cause the development of these folds, as they are capable of being crumbled off or buckled into folds. The folding is the process of development of folds. However, they may develop in variety of ways, right? So, so in this now, what do geologists infer from these folds? So, like observations, right? Observations in the field seldom provide geologists with complete information. Either bedrock is obscured by overlying this soil or erosion. It has removed much of the evidences, right? So, geologists search for these clues which desper the relation of this one bed to another. So the folds are significant in geological studies because of the some of the reasons. So those are bring the deep-seated rocks of the surface of the earth, and also facilitate development of site for deposition of mineral-bearing solutions, and serve as good host for oil and natural gas, and also create beautiful landscapes which may enhance geotourism. So these are the geological studies. Maybe these are the reasons, right? So now you see this is also another picture. So elements of folds now. Elements means wavelength. First, we are going to this wavelength, right? So wavelength of fold. So we have already know about that fold. So the folds are the wave-like undulations, right? Undulations found in the which one? Layered rock. So the wavelength of fold is the minimum distance between its two this successive points, right? These successive points of same phase. So it can also be defined as the distance between two alternating infections of points, right? This points. So so it is the in you see this is the picture fold geometry, right? Now you see we're going to parts of folds. What are those? So those are limbs, hinge, hinge zone, axial plane, and axial trace, and crest, trough, and inflection point, and also interlimb angle. So these are the parts of the folds. Now, what is the limb? So limb, it is a portion of a fold between inflection point and hinge, right? So the two sides, right? The two sides are flanks of the fold, sloping away from the hinge zone, right? So it's called limb. You see here, this one, limb, okay? Limb. Now, hinge zone. So hinge zone means the area of maximum curvature where the two limbs of the fold meet, right? Where is this hinge zone? Here. You see here, this one hinge zone. So sometimes the maximum curvature of the fold is not at a point, right? So, but in a zone called hinge zone. So this hinge zone is a region where the dip of the this folded surface changes over small distance. So such a region is also called a fold closure also, right? So this is the hinge zone. And next one, so here hinge line is also missing. Hinge line, right? Hinge line. What is this hinge line? This line, right? Hinge line. So hinge line, it is the locus of hinge points of a particular bedding plane, right? So this hinge line of a fold is the line maximum curvature in the folded folded bed, right? And also, in other words, we can say that hinge line is a line, right? Line along which change in the direction of dip takes place. And on many folds, this coincides with the amount of maximum curvature, right? Next one is axial plane, right? Axial plane means an imaginary plane that passes through the hinge zone, this hinge zone. So it dividing the fold into two halves. So it is a surface formed by joining of four hinge lines of successive beds. So when the axial surface forms a plane, it is called axial plane, right? Now axial trace. So the line on a rock bed where the axial plane, this intersect it, right? This intersect it. So that is called axial trace. And also crest. Crest means the highest point of the fold, highest point, right? So what is that? It is this that point which is located highest in the profile section of the fold, right? And next trough. So trough is the lowest point of the bed. So remember, crust is highest point of the fold and trough is lowest point of the fold, right? So it is that point which is located lowest in the profile section of a fold, right? And inflection point. So that is the point on a limb where the curvature changes direction, right? Inflection point, right? So the inflection point, it is a point of the fold, right? Fold with zero curvature, right? So zero curvature where it is form changes, right? So that is to say it is the point where an antiform changes into antiform changes into which one? Sync form, right? Sync form on cross section, right? This cross section of the fold or vice versa. So this is called inflection point. And next, interlimb angle. Interlimb angle means that is the angle between the which one? Two limbs of the folds. These two limbs, right? These two limbs of the folds. That is called interlimb angle. You see here, this one, right? Now you see here axial plane, plunge, crest, trough. Here also I wrote here. So axial plane, the imaginary plane which is equidistance from is limb of a fold and which also bisects the angle between the two, right? So this is axial plane and plunge and crest and trough, right? So now the classification of the fold causes of and also here the classification of folds. You see here, those are based on different principles. It can be classified as what is that? Based on outer surface profile and based on upward and downward bending and based on position of the axial plane and based on degree of composition and based on mode of occurrence and based on plunge of the folds and based on behavior with width and based on relative curvature of outer and inner arc. And last one is miscellaneous folds. So these are the classification of the folds, right? So now in this we are important topic. Uh, this is the they are asking in your examination, right? So what is the fold? The bending of the rock strata, right? Due to compressional forces acting tangentially or horizontally towards a common plane from opposite direction, right? That is called folding. So it is also defined as wavy undulations in rock beds forming crest and trough, right? So what is this? This is called crest and this is called trough. Trough, right? So in alternate manner, right? So now elements of folds I already told here. Axial plane. Where is the axial plane? So this one, right? This one called axial plane. Okay? This one called axial plane. And this is called axis of axis of fold. Okay? This is limb. This one is called limb. Okay? Limb. Axial plane, axis of fold, limb, crest, and trough. Right? So what is the trough? The trough is the line, this occupying the lowest part, right? This lowest part of the plane formed by all trough is called trough plane, right? So what is the crest? This is the line occupying the which one? This highest place, highest part of the fold, right? So the plane formed by all the crust is called crustal plane. So that is simple. Okay. So now in that classification, we have very important things here. So that is anticline, syncline, syncline, right? What is the anticline? An anticline is a this one, right? So this one. So this anticline is a this convex, right? Convex upward fold. So it may be defined as a fold that has older rocks in the center. So in Greek, this anticline means this opposite, right? Opposite inclined, opposite inclines. So it referring to the two limbs. So this is also one other limb. This is also another limb. So these two limbs dip away from each other, right? So this is the anticline. And syncline means, and syncline, this one, right? This one is called syncline. So syncline is a convex downward. So this is upward and this is downward fold. It may be defined as fold that has anchor rocks in the center. So in this anticline, the older rocks in the center, older rocks, remember. So here which rocks? Anchor rocks. Okay, anchor rocks. So in Greek, syncline means the together, right? Together incline. Here this is opposite incline in anticlines. So synclines to here together incline, it referring to the these two limb dip towards each other. Okay? You see here. Okay, this is anticline. You see, this is the real picture, right? You see, you observe this one. Okay, this is the anticline. So this is the syncline. Okay, anticline and syncline. So you see here, based on upward and downward classification, depend based on upward and downward bending, it classified as anticline and syncline. You see here, when the beds are bent upwards, the resulting fold is called anticline. So this fold is convex upwards. Naturally, in such a fold, the older beds occur towards the concave side. In a simple case, the limbs of anticline slope in opposite direction with reference to its axial plane. But when the anticline is refolded, the inclined character of limbs will be complicated. So this is the anticline. Right? So these are the 5 marks question. In your examination, they are asking 5 marks question. Right? Now you see here, syncline. Syncline is just opposite to anticline, right? So its nature, that is when the beds are bent downwards. Here, you looks here like this. These are the syncline. Okay, this is the real picture. So the resulting fold is called syncline. So this fold is convex downwards. So in this, the younger beds occur towards the concave side and in a simple type of syncline. So it limbs, what is the limbs? These are called limbs. Okay. So these limbs dip towards each other with reference to the axial plane. So these are the 5 marks question. So anticline or syncline, they are asking 5 marks question. So you can draw the picture like this. Okay. like this. So this is called anticline, and these are the limbs, right? Limbs. Okay, simple. Simple, you draw this figure like this. And syncline also same. Okay, so these are called limbs. So this is called syncline. Okay, so now, so anticline is over, syncline is over. And another one is symmetrical, right? Symmetrical, symmetrical fold. So what is the symmetrical fold? So in this case, the axial plane. Now you see, just wait, we'll show the figure. Okay, you see here. So in this case, the axial plane is, you see, this axial plane is vertical, and these two limbs, these are the called limbs, right? These two limbs dip at same angle, right? Same angle, but in opposite direction, right? Opposite direction. It passes through crest and trough, right? Crust and trough. So this is called symmetrical fold. So now we are going to asymmetrical. Asymmetrical means opposite of the symmetrical, right?